Hey guys, welcome back. All right, so today we are going to look at the zero product property. All right, and we're going to figure out how does it help us to find solutions of equations and what do these solutions mean. So I've given you a diagram to put in your notes and we've got some instructions over here. It says look at the diagram, circle all of the x-intercepts. Okay. So let's circle all of our x-intercepts. Well, what is an x-intercept? Intercept. Very similar to intersect. All right. X-intercepts is anything that is on the x-axis. So if we look at our x-axis, I have an x-intercept here, here, here. See any others? Oh, I got another one here. And the last one down there. So, x-intercepts, any place where our graph, okay, this is a goofy one. This is a polynomial. See, it's got x to the 5th degree. So notice 1, 2, 3, 4. It has a maximum of 5 x-intercepts, and that's all because of this. Now, a maximum, it doesn't have to have 5. So it asks us to identify all of their coordinates. Okay, so I'm just going to start from left to right. So if I look from the origin, I go 1, 2, 3 to the left. So -3, and I don't go up or down, so -3, 0. That's the coordinate of my first one. All right, and then next, same thing from the origin, left 2, up or down 0. Next one, -1, 0. And then we're going to the right, so +1, 0. And 1.5, I want to say, 1.5, 0. Looks about in the middle. What do all of these x-intercepts have in common? Do you see anything? Anything sticking out to you? Okay. Notice. Look at all of our y values. All of the y values are 0. So, come back. It's called the zero product property. So, our x-intercepts. They are also known as zeros. They are also known as roots. And they are also known as solutions. All of these words represent x-intercepts. So they could ask you, find the zeros, find the roots, find the solutions. It's all x-intercepts. It drives me nuts about the solutions things because I know that confuses people when they're finding different solutions. They're like, what do you mean? Well, if we're finding the solution, usually we're finding where y equals 0, and that's the key here. All of these represent when y equals 0. Okay? So, let's see. It says identify the solutions. Now notice, these look a little bit different. Okay? We have 3x times the quantity x minus 5 times the quantity 2x plus 3 equals y. And it said, find the solutions. Well, again, what do we know about solutions? These solutions are all about when y equals 0. So I'm going to come back, and I'm going to replace my y with 0. Right now, this is in factored form. 3x, x minus 5, 2x plus 3. Now, what we've been trained to do is go ahead and start multiplying, start distributing the 3x. And then whatever you get, distribute all that. Well, that's not what we're trying to do here. We're just trying to find the zeros. So I want to know what makes each piece equal to 0. Each piece equal to 0. So these are simple little 1 and 2 step equations, so each piece equal to 0. What would make 3x equal to 0? Well, it's 3 times x divided by 3. 0 divided by any number, remember that's okay. It just means it is 0. So that's our first solution. X minus 5, what makes it equal to 0? Well, add 5. X equals 5. 2x plus 3 equals 0. Solve it up. Solve it for x. What are we going to do? So, inverse of addition, subtract 3. 2x equals negative 3. How do we get rid of that 2? 2 times x, so divide by 2. X equals negative 3 halves. So our solutions, I'm just going to list them least to greatest. Negative 3 halves, 0, and 5. These are called curly brackets. It's just a notation that we have in math. So when you're looking for zeros, when we're looking for roots, solutions, it's all about the x-intercepts. So if we were to graph this polynomial, we would hit the x-axis at negative 3 halves, 0, and 5. Okay? So we're going to use this a lot more later, but for right now, we're just looking at it to find what are our solutions. What would make when the y equals 0, what is x? Essentially, that's what we're looking for. All right, go ahead. I'd pause the video and try the next one on your own. Okay, so when I set each of these equal to 0, now if you set negative 2 equal to 0, that doesn't do anything. Or you can keep the negative 2 attached here. That'll work too. So negative 2 times the quantity 3x minus 5 equals 0. So I got a couple different things. I can distribute, or I can divide everything by negative 2. I'm thinking most of you would probably think to distribute, so that's what I'll go with. So negative 6x plus 10 equals 0. So I would undo this addition, so subtract 10. Negative 6x equals negative 10. Divide both sides by negative 6. X equals, let's see, 2 goes into both, so negative divided by negative becomes positive 5/3. Okay, and then x plus 3, easy peasy, subtract 3 from both sides. X equals negative 3. So our solutions are negative 3 and 5/3. So this equation would have 2 zeros, 2 roots, 2 x-intercepts. That's it. That's all for today. All right, go ahead and try that practice. This will be a good, nice, easy lesson for a Friday. See you guys tomorrow.